transform is very essential whenever it comes to solving a problem using convolution. Let's take a problem. So the problem is like this. We are having a signal x1n as 1 by 4 raised to n u of n minus 1, and second signal is x2 of n is nothing but in bracket 1 plus 1 by 2 raised to n u of n. Now the traditional techniques that we know is the graphical and tabular, but tabular method we cannot use because it's not a finite length sequence, and for a graphical we need to plot this complicated signals. So whenever such problems arise, Z transform is the most effective tool. So let's check how we can get a convolution of these two. So the heading is find convolution of x1 of n and x2 of n. So what we'll do, we'll first concentrate on the first signal, that is x1n. Now along with the convolution property, here we have to use a shifting property as well, because here n minus 1 and n. So I'm adjusting over here n minus 1 like this. So in the end I will get x1 of n as 1 by 4 into 1 by 4 raised to n minus 1 u of n minus 1. Now just concentrate on this part. We will take simple signal 1 by 4 raised to n u of n minus 1. It's a given signal. Out of this, we know this is shifted or delayed by 1. So the original signal is 1 by 4 raised to n u of n. So what we'll do, we'll take a Z transform of 1 by 4 raised to n u of n, which is nothing but 1 upon 1 minus 1 by 4 Z inverse. And then we are using a time shifting property of Z transform. So in the end, Z transform of 1 by 4 raised to n minus 1 u of n minus 1 will be, since it is shifted by 1 or rather minus 1 unit, so Z inverse need to be multiplied with a Z transform of earlier signal. So in the end I will get x1z as, remember we have taken a Z transform of this signal, 1 by 4 constant will remain as it is. So in the end it will be 1 by 4 into Z inverse upon 1 minus 1 by 4 Z inverse with ROC. So over here 1 by 4 Z inverse and a u of n is there, that means we will get mod Z is greater than 1 by 4. It is outside the circle corresponding to a radius 1 by 4, origin at the center. So this is x1z. Remember here shifting property has been also used. Let's concentrate on the second signal then, x2n, which is 1 plus 1 by 2 raised to n u of n. What we'll do, we'll simply solve this bracket, so you'll get u of n plus 1 by 2 raised to n u of n. So here we have to take a z transform of these two signals, and in the end we can add them. So z transform of u of n is nothing but 1 upon 1 minus z inverse with ROC mod z greater than 1, and z transform of 1 by 2 raised to n u of n will get 1 upon 1 minus 1 by 2 z inverse with ROC mod z greater than 1 by 2. Now x2z will be nothing but addition of these two z transform, so in the end it will be 1 upon 1 minus z inverse plus 1 upon 1 minus 1 by 2 z inverse, and most importantly ROC will be intersection of these two. So intersection of these two is quite simple. Here mod z is greater than 1, here mod z is greater than half. So obviously for the causal signal the ROC will be outer to the outermost circle, and outermost circle is this. So in the end the intersection of these two ROC is nothing but mod z greater than 1. So here we are getting a x2z. Remember, along with the convolution all the properties is getting tested. Then if we sum x1z and x2z, we will get 1 by 4 z inverse upon 1 minus 1 by 4 z inverse multiplied by 1 upon 1 minus z inverse plus 1 upon 1 minus 1 by 2 z inverse, and the ROC will be intersection of these two ROCs. So mod z greater than 1 by 4, here mod z greater than 1, so obviously the resultant ROC for this will be mod z greater than 1. Now our job is to find out, rather simplifying this and taking a inverse z transform. So let's quickly simplify this. So the given function is this. Remember, whenever we are simplifying this, make sure that all the inverse orders of z you are making positive. Means what? I'll write over here 1 by 4z, here 1 minus 1 by 4z, here 1 upon 1 minus 1 by z plus 1 upon 1 minus 1 by 2z. Rest of things are just a simplification, so I will quickly do it. So I will get this. Let's solve this. So if we simplify, we will get x1z into x2z as 4 times z square minus 3 times z upon 4z minus 1 z minus 1, 2z minus 1. Now we will do one thing. Let's consider y of n as the answer for convolution of x1 and x2. And if you take a z transform of this, we will get y of z is nothing but a z transform of convolution of x1 and x2. And since we know the convolution z transform is nothing but x1z into x2z. So in the end, x1z into x2z is nothing but yz. So we'll write over here yz equal to, I'll take a z common, here I'll get 4z minus 3 divided by 4z minus 1, z minus 1, 2z minus 1. Now we have to take an inverse z transform of this. Whenever we are having a linear factors, we will do one thing, we will always do the partial fraction of y of z by z. So y of z by z in this case will be 4z minus 3 upon 4z minus 1 into z minus 1 into 2z minus 1. So we have to do a partial fraction of this. So we'll take 4z minus 3 upon 4z minus 1, z minus 1, 2z minus 1. All the factors are linear, so it's a divided by 4z minus 1 plus b divided by z minus 1 plus c divided by 2z minus 1. Let's quickly find out the residues a, b, c. So how to find out a? So a is nothing but, we have to take that portion of this transfer function except 4z minus 1, meaning I have to evaluate 4z minus 3 upon z minus 1, 2z minus 1 at z equal to 1 by 4. So if I put this value, I will get 4 into 1 by 4 minus 3 upon 1 by 4 minus 1, 2 into 1 by 4 minus 1. So 4 get cancelled. So basically over here I am getting this as 1 minus 3 upon minus 3 by 4 multiplied by, here also I'll get 1 by 2 minus 1 as minus 1 by 2. So if I simplify this, what I will get, minus 2 upon 3 by 8, and ultimately this will be minus 16 by 3. This is the shortest way to find out the residue a. Now let's find out b. So once again, same transfer function except z minus 1. We have to evaluate at z equal to 1, which is nothing but 4 into 1 minus 3 upon 4 into 1 minus 1, 2 into 1 minus 1. So what I will get over here, 4 minus 3 upon 4 minus 1, 2 minus 1. So in the end I will get b as 1 upon 3 into 1. So it's a 1 by 3. Let's find out a c in same manner. So c is 4z minus 3 upon 4z minus 1 into z minus 1. I have to evaluate at z equal to 1 by 2. So 4 into 1 by 2 minus 3 upon 4 into 1 by 2 minus 1 and 1 by 2 minus 1. So it is 2 minus 3 upon 2 minus 1, 1 by 2 minus 1. So it's a minus 1, 2 minus 1 is 1 into minus 1 by 2. So after simplification, this will be 2. So in the end, I will get A as minus 16 by 3, B as 1 by 3 and C equal to 2. So that this I can write as yz divided by z as A is minus 16 by 3 divided by 4z minus 1, B as 1 by 3 divided by z minus 1 and C as 2 divided by 2z minus 1. And now let's take the use of this z. So in the end it will be minus 16 by 3 into z upon 4z minus 1 plus 1 by 3 into z upon z minus 1 plus 2z upon 2z minus 1. Now what is the use of this z? I will do one thing. I will cancel out z from all this, numerator and denominator, so that I will get y of z as minus 16 by 3 bracket 1 upon 4 minus z inverse plus 1 by 3 1 upon 1 minus z inverse and finally plus 2 1 upon 2 minus z inverse. You are almost on the verge of getting the final answer, except you need to adjust the first term in the denominator of each term, meaning I will take a 4 common, I will get 1 minus 1 by 4 z inverse. So this is first term 1 by 3. Here it is in a perfect form, no need to do anything. Here I need to take 2 common, so that in bracket 1 minus 1 by 2 z inverse will be left. So I can cancel this 4, I can cancel this 2. So in the end of y of z I will get as minus 4 by 3 into 1 upon 1 minus 1 by 4 z inverse plus 1 by 3 1 upon 1 minus z inverse plus 1 upon 1 minus 1 by 2 z inverse. What is the use of this? Because every term over here will give you a raised to n u of n or a raised to n u of n minus 1. All depends upon what is the ROC. So here comes the technique of ROC. So in the end we got a ROC as mod z has to be greater than 1. For this ROC we need to check what would be the final answer. So what we will do over here, we will plot poles and zeros. The Z plan. So here if you see properly, I am getting a 3 circles, one of a radius 1 by 2, second of a radius 1 by 4 and third of a radius 1. So this is mod z equal to 1, mod z equal to 1 by 2, and over here mod z equal to 1 by 4. Our ROC is mod z has to be greater than 1. So it is outside the outermost circle. Since the ROC is outside the outermost circle, obviously it is exterior to remaining circles as well. So for both the circles, ROC is outside the circle. Outside the circle means we are having u of n in a expression of each term. So finally, taking inverse Z transform, we will get y of n as minus 4 by 3, 1 by 4 raised to n u of n plus 1 by 3, 1 raised to n u of n plus 1 by 2 raised to n u of n. So this will be the convolution of x1 and x2. Remember, this is the shortest technique to solve a problem, because otherwise it will take a lot of time whenever you use the graphical method. So this is the power of Z transform. Thank you.